Hey guys, welcome back. Najkazi here. In today's video, I'm going to discuss Section 1, Part 2 of the CCNA exam. The first thing I'm going to talk about is network architectures, LAN architecture and WAN architecture. In particular, I'm going to give you the Cisco hardware portfolio overview of the switches and routers, so you get to learn how to pick the right type of switches for your environment and right type of routers, and whether or not SD-WAN is the way to go or non-SD-WAN. We'll discuss some of those details. I've also done separate videos on the topic of SD-WAN, so you can watch my SD-WAN playlist there. This is going to be an exciting video, guys. I can't wait to share. So without further ado, let's roll. Welcome to CCNA 200-301 course. Today, we're going to look at Section 1, Part 2. We're still dealing with network fundamentals, but what's different is that we're now looking at network architectures and basics of Cisco CLI. Here are the topics I plan on covering today. First, we'll look at network architectures and two particular type of network architectures in particular, LAN architecture and WAN architecture. And finally, we'll look at basics of Cisco CLI. Let's jump right in. From a LAN architecture perspective, we have the infamous three-tier campus network design. And what we have in this architecture is we got these access layer switches that have the PCs plugged in, laptops. We could have servers plugged in here, different devices. We could also have a voice over IP phone plugged in to the switch directly. So these are the end devices here at the access layer that needs to be connected to the network. Taking a step back here, a switch is a very important device when it comes to building a network. That's one of the most fundamental components you need to start building a network. And access layer provides access to the different endpoints, like I said, right? So we got endpoints that are connected to the access layer switches. What ends up happening next is that we have distribution layer switches. And in distribution layer, these are basically aggregation switches that are taking a bunch of connections from the access layer switches and combining them into a distribution layer, also called aggregation layer. And here, the idea is that we got all these different connections coming from the endpoints. It becomes a point of consolidation. It handles all the different links that are coming from the access layer switches. And in particular, we call these links that are going up and getting plugged into the distribution layer switches from the access layer, uplinks. They're very conveniently named uplinks. All the links that are facing the clients and the endpoints, these are called downlinks. Okay, so this is an important terminology to understand. When somebody says, where's the problem, downlink or an uplink, immediately you should get this picture in your head as you're troubleshooting, a picture where you understand that the downlink means the ports that are facing the endpoints, and the uplinks mean interfaces that are facing the switches upstream. And finally, we have a core layer. And the whole reason we have a core layer in our network is to consolidate a bunch of distribution layer switches. So this comes into play. This type of model, a three-tier campus model, is suited for large enterprises. You're looking at Fortune 500 companies, possibly up to Fortune 5,000. But these are gigantic, large corporations with a ton of locations. And what you end up doing is you take a bunch of different buildings and you consolidate them together and interconnect them together. And core layer is what connects those different buildings together. So for example, in building 1, you'll have distribution layer switches in building 1. And then you have building 2 that has its own distribution layer. Then you have building 3 that has its own distribution layer switches, building 4 same thing, and so on and so forth. Well, how do you connect all of these distribution layer switches together? One way would be to actually interconnect them all in a full mesh, and full mesh gets really, really ugly really quickly. You wouldn't want to do that. Instead, what you do is you have these distribution layer switches, and we end up using one of the buildings as the primary building. So let's say building 1 might become the core of our network. And this is where we would install core switches, and all of the distribution switches from different buildings would physically run their cables and get plugged into the core into building 1. And that's why we need this 3-tier hierarchical architecture. And another reason we need hierarchy is because it's easier to troubleshoot, it's easier to design our network, plus it's easier to make purchasing decisions. When you're looking at buying access layer switches versus distribution layer switches or core layer switches, each layer serves a different purpose. So it makes your choice as an end user a lot easier to decide how to plug different switches into each layer. So it makes it like a Lego block type approach where you just fit the different blocks into the different layers for its own purpose. Next, let's look at the 2-tier network design. In this model, what we have is we got these endpoints at the bottom, our phones, PCs, laptops, IP phones, and all that. They're all connected here at the bottom directly into the access layer switches. And then we got we call this a collapsed core. Or we can call it a core/distribution layer. So here we don't necessarily need a separate core layer. And where this comes into play is if it's a small to medium-sized business where you don't have a lot of locations. Let's say you started a brand new business and you got building 1, and a few months later you got building 2. Your network is not that large. You can get away with just having a bunch of distribution layer switches interconnected together in both buildings. It isn't until you start adding more buildings and your network grows to a certain point that you would actually even consider looking at adding core switches. And next, I would like for you to look at the modular campus network design. This is taking the access and distribution and core. So here the picture is flipped. So we got the access switches all the way up at the top. This is where the endpoints are plugged in, right? Then we got a bunch of these links coming from the access switches into the distribution for aggregation, right? So that's our aggregation point. And from there, we further consolidate and interconnect into the core. And the whole idea is core is where you would have your wide area connection, for example, at the bottom, as you can see. Or you can have your data center connected or internet. And you might say, well, whoa, what is this? Well, up at the top, you got our standard campus design, right? Access, distribution, core. At the bottom, we got access, distribution, and core for interconnecting different services. For example, these endpoints that you have plugged in. So if I'm a user up at the top, let's say if I'm Bob, and I've got a desktop that's plugged into one of these switches, well, what does Bob need to do his job? Well, Bob would need to connect to either a wide area network to access some applications, or perhaps maybe some server that's sitting in a data center plugged into, let's say, one of these switches at the bottom here. Or Bob may need to access the internet, maybe Google something or whatever, right? Or maybe watch cat videos on YouTube if Bob has nothing better to do, right? It's all possible because of this architecture. So Bob would interconnect to the access would interconnect him to the distribution will connect him to the core. Core is where the internet is plugged in through its own access, distribution, and core. And then finally, it will allow access to Bob And this is how the traffic flow may look like. Traffic flow might take a different path, but for simplicity reasons, let's say this is the path that traffic took to allow Bob access to the internet. So this is what's called a modular campus design. We have these modules that we use to allow access to our end users, because ultimately the network exists for what reason? The entire reason for setting up a network is to allow users access to different applications so they can do their job efficiently and effectively. That's why we build networks. And as network engineers, we're concerned with how all the different network devices interconnect with each other and allow the traffic to flow through. And that's our job. Now, next, I would like to give you a quick review of the Cisco campus switching hardware portfolio. But before I take you to Cisco's website, a couple of things I want to bring to your attention. There are three main types of switches. You got the fixed configuration switches, you got the modular configuration switches, and then you got the stackable configuration switches. And I'm going to go through each type on Cisco's website. A couple of things to consider before you make a purchasing decision. You need to think about how many ports you need. You also need to think about, are you buying switches for your access layer or distribution layer or core layer? Or are you buying switches for the entire network? If it's a brand new location and a brand new site, maybe you need switches for all three layers. Or maybe you're a brand new business and all you need to do is just have 2 layers instead of 3-tier architecture. You could do that too. But these are the things you have to consider. You have to think about the port density. How many ports? Do you need a 24-port switch or a 48-port switch? What do you need? Switch throughput. What kind of throughput? Do you want a line rate throughput? Line rate throughput would mean that if you have a 24-port switch and each port happens to be 1 gig, that's 1 gig times 24. That's 24 gig. So that means that you need a switch that has the ability to operate at a full 24 gig. There is no contention ratio, meaning there is no bottleneck. Each port is able to access at a line rate. Typically, that's not the case. In campus environment, you don't need switches because those end up becoming really expensive switches. When you want to get wire speed switches, they end up becoming very expensive. Typically in a data center environment is where you would want switches that have no contention ratio. In campus environments, you're going to have 8-to-1 type ratio is very common, 4-to-1, 16-to-1 type of ratio. You're going to see stuff like that. The next thing you need to consider is PoE, or power over Ethernet. And this is important because it just depends how many voice over IP phones you have in your environment. So if you're going to have a lot of voice phones or SIP phones, you're going to need PoE, power over Ethernet, meaning those switches get their power from the Ethernet cable. You don't have to plug them in separately into using an external power supply. Instead, the Ethernet port that's plugged into the phone powers it up, versus non-PoE. So we also call that data port. So data port versus voice port. You need to define how many ports you need. Plus, you need to decide whether you need a copper switch or fiber switch. Once again, in a campus environment, copper switch is very common. You may need a couple of fiber switches to connect the different floors together, for example. You also need to consider power. Do you need redundant power? Do you need a switch that has multiple power supplies in it? And finally, scalability. Does your switch allow you to grow as your environment grows, or are you stuck with that switch? Meaning, if you get a fixed configuration switch, as I alluded to earlier, and if it's only 24 ports and you got 24 users on that floor, you're done. The minute you hire a 25th person, now you need a new switch to be installed on that floor. So something to think about. And that's what I mean by scalability. Now, without further ado, let me take you to Cisco's website so we can do a deep dive. So what we'll do is we'll go to cisco.com. So we go to products, networking, switches. Once we come to this page, what we want to do next is we want to scroll down and you want to get to a point where it says view all Cisco switches. Click on that link and you will be absolutely blown away when you look at this, especially if you're brand new to networking and you haven't really worked with switches before. And let me explain what I mean. So look at how many different categories of switches you got. Blade switches, campus LAN, data center, industrial, Ethernet, InfiniBand, LAN network management, blah, blah, blah. I don't want you to get overwhelmed. The only type of switches you want to pay attention to are these switches right here, campus LAN access. You want to look at campus LAN core and distribution, and that's it. These are the only two type of switches I want you to be concerned with. Later on in the course, you can also look at data center switches, but right now I don't want you to get overwhelmed. Let's focus in on campus LAN switches and the core and distribution switches. That said, now let's go ahead and click on the access switches. Now here are the different categories of access switches. What I want you to pay attention to is Cisco released their Catalyst 9K or the 9000 series a couple of years ago, and this is the series that Cisco has been pushing the most lately. So if you're in the market looking to purchase switches, this is the series you need to be focused on. You need to be looking at Catalyst 9200, 9300, and 9400 switches for your campus access. And these 9400 switches could also be potentially used as your distribution / core collapsed as well. And I'll tell you more about it in a moment. And if we were to look at the campus LAN core switches right here, you'll see we got the Catalyst 9600. It's a fairly new series. It was launched a couple of months ago. Catalyst 9500, don't worry about the 6800. Cisco is eventually going to sunset the 6800 platform. 6500s have been around forever, so forget about that. And some of these other switches are kind of going away as well. You primarily need to focus on the Cisco Catalyst 9K line or the 9000 series. That's what you need to be focused on. Now, let me take you to the 9200 series. Let's take a look at that. As you can see here, these are fixed switches. And let's look at the different models that they offer. What I would suggest is every time you look at a switch, the best way to learn more about it is you look at their data sheet. And Cisco does an amazing job with their data sheets. I really like their data sheets. They do a really good job. So it will tell you how many ports maximum, what type of capabilities, whether or not you have redundant power supplies or not, redundant fans, whether or not you have different additional capabilities, layer 3 and whatnot, and what type of throughput overall, whether or not these switches are stackable or not. As I mentioned, we have 3 different types of switches. We got the fixed switches, we got the modular switches, and we got the stackable switches. Now these 9200 series switches, they fit 2 categories. They fit the fixed switches category, and they also fit the category of stackable switches. And let me show you here. You can see, if you continue scrolling down, you can see how many ports, how many downlinks, like I said, and uplink. So it kind of shows you what type of capacity you got. And you got the modular uplink models, meaning you have the ability to install uplink modules yourself, and you can pick different types of configuration, or you can purchase switches that have fixed uplink modules in them. And these are the network modules I'm referring to, the ones that have the ability for you to install. You pick one of these. Like for example, 4x1 gig. You can do 4x10 gig. 4x10 gig means 4 interfaces of 10 gig each. 4x1 means 4 interfaces of 1 gig each. So on and so forth. And these switches have redundant power supplies in them. As you can see, each power supply has a single power cord connection coming out of it. So you need to make sure that you have redundant PDUs or power distribution units that these switches are going to get plugged into. And the modularity means that you have the ability to be able to slide different modules out and slide them back in. Also, these switches have the ability to be stacked. So that means maximum number of switches that you can stack together are 8. And let me show you a picture of a stacking configuration. So here's a picture. So basically this is the back side of these Catalyst 9200 switches. And what we're looking at are these stacking cables. And see how they're connected together, right? And what that means is, in this picture, we're seeing 4 switches being stacked together via these stacking cables. Even though physically they're 4 separate switches, but when you use stacking cables, what it does is it makes them appear as a single switch instead of 4 different switches. So one of these is going to become primary when you stack them up like that. Let's say the first one here becomes a primary switch. When you log into it via CLI, and we'll talk more about CLI in a moment, command line interface, what ends up happening is you see if each of these has 24 ports, 24 times 4 is 96 ports, right? So what you're going to see in CLI is, like, literally, you're going to see as if you have a single switch with 96 ports on it, instead of 4 different switches with 24 ports each. So it's really unique, it's really interesting, makes a lot easier for you to configure. Also, the control plane combines, that makes it really, really interesting. It makes the configuration a lot easier. You can take advantage of redundant links operating in active fashion, things of that nature. So that was the overview of 9200 series. Now let's go ahead and take a look at the 9300 series. It's very similar to the 9200 series, and let's go ahead and take a look at the datasheet of the Catalyst 9300. These are the next class of switches. 9200s are the most basic bare bone switches you can get, whereas 9300 have a lot more horsepower and much better overall throughput. They're also stackable switches, by the way, and very similar configuration, 24 port, 48 port. You got data only switches, you got PoE plus switches, or UPoE, universal power over Ethernet. These suck up more power, so you'll see, stronger, bigger, better power supplies on these compared to the ones that are just PoE plus, for example. We'll talk more about PoE later in the course. And once again, you got the modular uplink capability, and then you got the fixed uplink capability, and you got all these different modules you can get. Power supplies, once again, you have redundant power supplies, you got redundant fans, so you have a lot of redundancy there. In case if one of the power supplies failed, the other power supply has the ability to completely take over and become the primary power supply, so you continue to run operations even if you had your switch had experienced a single power supply failure. That's pretty much it for the 9300. And now let's quickly take a look at the 9400, because this is a very interesting series, because this is a cross between distribution / core. So let's quickly look at the datasheet here. And these are modular switches, by the way. And modular switches are chassis based, and you'll see what I'm talking about when the picture shows up. But these switches, as you can see, they take up a lot more rack units. Instead of, like a 1U or 2U, these are much larger in size. By the way, there's a couple of other things you want to think about when it comes to modular switches, and that has to do with the fact that modular switches require line cards, and line cards are essentially the interfaces that you need, right? So an example of a line card would be, here's an example of a line card. You got this line card that is all RJ45, and you have the ability to plug in copper ports. So this is a copper line card. This right here is a fiber line card. You can plug in fiber connections in here. And this is how it would look like once you plug in all of your line cards and soup modules. Now, another thing I want you to understand and keep in mind is that on these modular switches, you need line cards that provide interfaces, and you need supervisor engine modules. And these soup modules, they're also called soup modules. These soup modules are the ones that are the brains of the entire switch. Without it, switch is just a shell. You need the supervisor module that has the CPU, memory, and all that. It is the brains of the entire solution, and it operates and it runs the switch. The reason you have two is for high availability and redundancy. Only one is active at a time. When the primary fails, the secondary supervisor engine takes over. Now, coming back to the slots, the 9404 chassis, even though it has 4 slots, you can only put 2 line cards in it because there are 2 dedicated slots for the supervisor engine. Same thing for 9407. Here you have 7 slots available, but you can only use 5 for the line cards and 2 for soup module. And then the 9410, once again, you have 2 slots that are dedicated to the soup module, and you can insert 8 line cards in this particular chassis. And a lot of it's becoming customers' new favorite switch. A lot of the customers I know are replacing their old Catalyst 6500s with these 9400 series switches, depending on how many modules they need. And you also got this 9600 series that was just recently announced a couple of months ago. Here's the CAT 9600 switch. Currently, it's only available in one configuration option, and that's 9606. That's the only option that's available today. Most likely Cisco will add additional options, but right now that's all you got. But it's a very, very powerful switch. In the Catalyst 9K family, this happens to have the highest capabilities. Like if you look at up to 9.6 terabit per second in a wired switching capacity with 3 billion packets per second. I mean, this switch is a monster, right? Up to 48 non-blocking 100 gig Ethernet, QSFP 28 ports. Like I said, this thing is an absolute monster for being a campus class switch. It's almost a data center class switch, in my opinion, in terms of the capabilities it offers, but it does have a lot of campus type capabilities, and that's why it's positioned as a campus core switch. And it's all about wire speed. Packets come in, packets go out, and that's the whole purpose of the core switch. Thanks for sticking around. By the way, there's a lot more to this video than what you have seen. In order to watch the entire video, you're gonna have to be a little patient because I'm working on designing an entire CCNA course. I'm gonna do an official launch in the next couple of months, but until then, I'm gonna keep putting little nuggets of the CCNA exam out there on my YouTube channel until the course is ready to be published. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.